On February 12, 2025, a significant Energy Subcommittee hearing took place under the auspices of the House Committee on Science, Space and Technology, focusing on the transformative potential of the Department of Energy's DOE National Laboratories. This session brought together leading experts from various national laboratories, including Dr. John Wagner from the Idaho National Laboratory, Dr. Tom Mason from Los Alamos National Laboratory, Dr. Paul Kearns from Argonne National Laboratory, and Dr. Kimberly Budil from Lawrence Livermore National Laboratory. Their testimonies underscored the vital role these institutions play in driving technological breakthroughs and scientific innovation. During the hearing, Dr. Wagner emphasized the laboratory's contributions to national security and energy independence, stating, "Our work not only supports the DOE's mission but also strengthens our nation's resilience against emerging threats." The discussions highlighted ongoing projects aimed at enhancing clean energy technologies and improving the management of nuclear materials, reflecting the laboratory's commitment to addressing pressing global challenges. This hearing coincided with a broader conversation about women's contributions to science, exemplified by the profile of Ally Peccia, a fourth-year Ph.D. candidate at Columbia University. Peccia is engaged in groundbreaking research on volcanic gases and their interactions with climate, showcasing how young women in science are paving the way for future advancements. Getting involved with science was never about committing to a single topic. It was about being involved in a process of learning and discovery, Peccia noted, reflecting the interdisciplinary nature of scientific inquiry today. Peccia's work not only contributes to our understanding of volcanic activity but also emphasizes the importance of mentorship in the sciences. She pointed out the need for institutions to focus on retaining women in senior positions, addressing the leaky pipeline phenomenon that often sees talented female scientists leaving the field. Her call for systemic change resonates with ongoing efforts to support gender equity in STEM. In a related initiative, William and Mary is blending the arts with environmental science by presenting the one-act play Rollover, which examines the impact of hurricanes on coastal communities. This innovative collaboration between the Batten School of Coastal and Marine Sciences and the Department of Theater and Performance seeks to raise awareness about pressing environmental issues through the powerful medium of theater. Nicole Millett, an assistant professor involved in the production, remarked, "Through performance we can create spaces where science, history and storytelling intersect, thereby enhancing public engagement with complex scientific topics." The importance of safeguarding coastal regions was also underscored at Florida Atlantic University, where the upcoming Future-Proofing Our Coasts lecture will address strategies for protecting vulnerable coastlines. This event is part of the Schmidt College of Sciences Frontiers in Science public lecture series, further illustrating the growing recognition of interdisciplinary approaches to environmental challenges. The confluence of technology, science, and the arts highlights a crucial trend in contemporary scholarship and public engagement. As we navigate the complexities of climate change and energy security, these multifaceted collaborations will be vital in shaping effective responses and fostering a deeper understanding of the issues at hand. Looking ahead, the integration of diverse perspectives from the scientific community, educational institutions, and the arts will likely play a transformative role in informing policy and inspiring future generations of scientists and advocates. In a groundbreaking study that promises to enhance our understanding of genetic regulation, researchers from the Gage Group at the European Molecular Biology Laboratory EMBL Grenoble have unveiled critical insights into the structure and function of the minor spliceosoma complex that plays a vital role in gene expression. Published in the journal Molecular Cell, this research sheds light on a lesser-known yet essential component of cellular machinery that has intrigued scientists for decades. The spliceosome is a crucial molecular assembly responsible for the intricate task of splicing, which involves removing non-coding regions known as introns from pre-messenger RNA, pre-mRNA, and joining the coding regions or exons together. This process is fundamental for the accurate expression of genes, with the major spliceosome handling the bulk of splicing tasks. In contrast, the minor spliceosome operates on a much smaller fraction of introns, specifically those that are particularly rare yet vital, often found within housekeeping genes necessary for cellular function. Zhangfeng Zhao, a postdoctoral fellow in the Gage group and the study's lead author, explained the significance of these minor introns, stating, "These minor introns are very rare but extremely critical because they are often located in housekeeping genes that are essential for supporting life." This highlights the importance of the minor spliceosome in maintaining cellular integrity and function. The researchers focused on U11SNRNP, one of the 5 subunits that comprise the minor spliceosome. Their study utilized advanced techniques such as biochemistry and cryo-electron microscopy to elucidate the structure of this subunit. The findings revealed that the U11SNRNP has a distinct architecture compared to its major spliceosome counterpart, U1SNRNP. This unique structure enables it to effectively identify and process its specific targets amidst the vast RNA landscape within cells. Zhao likened this task to finding a needle in a haystack, emphasizing the complexity and precision required for the minor spliceosome's function. The evolution of these spliceosomal complexes is also a focal point of the research. According to Wojciech Gage, group leader at EMBL Grenoble, the major and minor spliceosomes are evolutionarily related, but they diverged more than 1.5 billion years ago. This long evolutionary history suggests that the functional distinctions between these two spliceosomes are deeply rooted in the biology of eukaryotic cells. Despite the progress made in understanding the minor spliceosome, Zhao acknowledged the challenges that lie ahead. "This has been a challenging project and we're making progress, but there's still so much to know about the minor spliceosome," he noted, indicating that further exploration of the spliceosome's assembly and activity is necessary. The implications of this research extend beyond basic science. Understanding the minor spliceosome's mechanism could provide new insights into genetic disorders linked to spliceosome dysfunction. Gage remarked, "Our long-term goal is to understand how this entire pathway works at the molecular level. This could ultimately lead to new therapeutic applications." As research continues to unravel the complexities of the minor spliceosome, it holds promise not only for advancing our knowledge of gene regulation but also for paving the way toward innovative treatments for genetic disorders. The path ahead is rife with possibilities, suggesting that the secrets held by this molecular machinery may soon contribute significantly to the fields of genetics and medicine. In a remarkable convergence of technology and medicine. Recent advancements in cancer research are leading the charge toward more personalized and effective treatment options for patients battling various forms of the disease. Notably, breakthroughs at Yale University and the University of Southern California USC are illuminating the path toward innovative therapies that could redefine the landscape of cancer care. At Yale, researchers led by Dr. Ranjit Bindra have developed a new class of chemotherapy agents designed specifically for glioblastoma, an aggressive form of brain cancer notorious for its resistance to conventional treatments. Glioblastoma affects approximately 13,000 individuals in the U.S. annually with a dismal survival rate. Bindra, along with Dr. Peter Glazer and chemist Dr. Seth Herzen, has engineered precision chemotherapy that targets tumors lacking a specific DNA repair protein MGMT, which is key to the effectiveness of the conventional drug temozolomide TMZ. "We call this precision chemotherapy," Bindra remarked, underscoring the innovative approach that customizes treatment to the characteristics of the tumor itself. The collaboration has already yielded promising results. Their new therapeutic agents are expected to enter clinical trials as early as 2026 following the acquisition of their biotechnology company Modify Bio by Merck for $30 million. This rapid transition from laboratory to clinic exemplifies the potential for swift advancements in treatment options derived from cutting-edge research. Meanwhile, at USC, Assistant Professor Ruishan Liu and his team have made significant strides in utilizing artificial intelligence to analyze genetic mutations across a broad spectrum of cancer types. Their groundbreaking study, which examined data from over 78,000 cancer patients, identified nearly 800 genetic alterations that impact treatment outcomes. By focusing on genes such as TP53 and KRAS, they aim to refine therapeutic approaches, allowing doctors to select treatments tailored to the genetic profile of each patient's cancer. By understanding how different mutations influence treatment response, doctors can select the most effective therapies, Liu stated, highlighting the shift towards precision medicine in oncology. The study's findings suggest that specific mutations can either hinder or enhance treatment efficacy, particularly in cases involving advanced lung cancer. Liu's team developed a machine learning tool capable of predicting patient responses to immunotherapy, which could lead to more informed treatment decisions and improved survival rates. In addition to these innovations, Yale's research has also shed light on the treatment of meningiomas, the most common type of intracranial tumor. Dr. Sylvia Kurz has spearheaded a clinical trial using a radiopharmaceutical drug Lutathera, targeting the SSTR2 protein overexpressed in these tumors. Preliminary results indicate that the treatment may significantly extend progression-free survival for patients with recurrent meningiomas. This is huge, Kurz noted, emphasizing the need for new therapeutic options for this patient population. Furthermore, Yale's interdisciplinary approach has led to the development of nanoparticle-encapsulated drugs that can bypass the blood-brain barrier, providing targeted treatment for medulloblastomas, a type of childhood brain cancer. The outcomes from initial studies are promising, paving the way for clinical applications that could revolutionize how these challenging tumors are managed. As science continues to explore the intricate mechanisms of cancer and the ways to combat it, the integration of artificial intelligence, molecular biology, and innovative drug delivery systems exemplifies a new era of oncology. These advancements not only promise to enhance treatment efficacy but also aim to personalize patient care, transforming the future of cancer treatment into a realm where therapies are as unique as the patients themselves. As researchers at institutions like Yale and USC push the boundaries of knowledge, the hope is that these breakthroughs will soon translate into tangible benefits for patients, offering renewed hope in the fight against cancer. In an era where technology is rapidly transforming agriculture, a recent study has revealed that trust in scientific methods is pivotal for the successful adoption of artificial intelligence (AI) in the farming sector. This finding underscores the complex interplay between innovation perception and practical application in agriculture, where the integration of AI could significantly enhance productivity and sustainability. The study, published by the Peccia on February 12, 2025, highlights that farmers' willingness to embrace AI technologies largely hinges on their trust in the underlying science. With agriculture facing mounting pressures from climate change, labor shortages, and the need for increased efficiency, the potential of AI to address these challenges is immense. However, skepticism regarding the reliability and applicability of these technologies can hinder their deployment. Farmers need to see tangible benefits and credible research backing AI solutions before fully committing, the report noted, reflecting a sentiment echoed by many within the agricultural community. The implications of this research extend beyond mere technology adoption. They touch upon the broader theme of how scientific literacy and trust can influence industry practices. As the agricultural landscape evolves, fostering a culture of trust in scientific advancements will be crucial for enabling farmers to harness the full potential of AI. This requires not only robust research but also effective communication strategies that can bridge the gap between scientists and practitioners in the field. In a parallel development, the Data Science Salon DSS is set to host its annual conference in Austin, Texas on February 19 to 20, 2025. This event is anticipated to be a significant gathering for data science and machine learning professionals, featuring discussions on AI applications across various sectors including agriculture. Brent Schneemann, the director of AI and software engineering at PMG, emphasized the importance of such gatherings, stating, "DSS-ATX is a high-bandwidth and well-curated opportunity to gather the community to learn from and collaborate with people from deep practitioners to the AI curious." The conference will not only spotlight established experts from major companies but will also provide a platform for startups to showcase innovative solutions. This aligns with the study's findings by promoting a shared understanding of the science behind AI and its practical applications. According to Gopinath Sundaramurthy Ph.D., the event offers a unique opportunity for participants to engage with real-world applications, which is critical for building trust in technology. As the agricultural sector increasingly looks to AI for solutions, events like DSSATX illustrate the growing recognition of the need for collaboration and education in this space. With a focus on inclusivity, the Data Science Salon aims to empower diverse voices in data science, further bolstering the community's capacity to drive innovation. Looking ahead, the integration of AI in agriculture appears poised for growth, provided that stakeholders can cultivate an environment of trust and understanding. The upcoming DSS events in other cities, including Seattle and New York, will continue to explore the intersection of AI, data science, and practical applications across various industries. As these discussions evolve, they may pave the way for a future where AI is not only trusted but also indispensable in tackling the pressing challenges faced by farmers today. In summary, the intersection of trust in science and technology adoption is crucial for the future of agriculture. With ongoing dialogue and collaboration within the data science community, the agricultural sector stands at the brink of a transformative era powered by AI. Provided that the trust factor is effectively addressed. In a remarkable turn of events in the global energy landscape, Canada has achieved a groundbreaking milestone in nuclear fusion, a development that could reshape the future of clean energy. General Fusion, a Vancouver-based company, has set a record by producing a staggering 600 million neutrons per second in a fusion reaction, an accomplishment that has garnered official recognition from the International Atomic Energy Agency (IAEA). This breakthrough not only marks a significant leap towards sustainable energy but also positions Canada as a leader in the quest for limitless clean energy alternatives. The achievement is rooted in a novel approach called magnetized target fusion (MTF), which leverages a mechanical plasma compression system within a spherical tokamak reactor. Unlike traditional methods that rely on costly superconducting magnets or high-powered lasers, General Fusion's innovation utilizes a liquid metal liner and a system of pistons to compress the plasma. The results have been nothing short of extraordinary, with plasma density increasing a remarkable 190 times compared to initial experiments, alongside a 13-fold enhancement in magnetic field strength that ensures optimal plasma confinement. As the world grapples with the pressing need to transition away from fossil fuels, General Fusion's technology offers a glimmer of hope. Scientists are optimistic that this cost-effective approach will finally bring clean and affordable energy within reach. This is a critical step toward making fusion energy a practical reality, said a spokesperson from the IAEA, emphasizing the potential impact on global energy consumption and environmental sustainability. The timing of Canada's triumph in fusion technology comes amidst a backdrop of shifting energy policies in the United States under the new administration of Energy Secretary Chris Wright. In his initial order, Wright called for a comprehensive review of the Department of Energy's research and development portfolio, prioritizing projects that promised true technological breakthroughs in energy innovation. While emphasizing the importance of nuclear technologies, specifically next-generation nuclear power, the order has ignited discussions about the future of energy development in America, particularly regarding its stance on renewable sources like wind and solar. Wright's approach has drawn mixed reactions, especially considering his previous skepticism towards climate crisis narratives and his criticism of policies aimed at achieving net-zero carbon emissions. His recent directive aligns with President Trump's administration's broader energy strategy, which has been characterized by a focus on deregulation and rapid deployment of traditional and advanced energy technologies. The convergence of these developments, Canada's historic fusion breakthrough and the U.S. Energy Department's renewed focus on nuclear energy, signals a potentially transformative era for global energy production. As nations vie to secure their energy futures, the implications of such innovations will likely extend beyond national borders, fostering international collaborations and competitive advancements in clean energy technologies. As we look ahead, the prospect of achieving practical nuclear fusion energy coupled with evolving energy policies could redefine the landscape of clean energy. The focus on cost-effective and sustainable solutions presents a compelling narrative for the future. One that promises not only to mitigate climate change but also to address the world's growing energy demands. The momentum generated by these recent breakthroughs raises the question, could we be on the cusp of a new energy renaissance that harnesses the power of the stars? Only time will tell, but the signs of progress are certainly encouraging. In a remarkable fusion of quantum computing and telecommunications, physicists have made significant strides in bridging the gap between qubits and fiber optics, a development that promises to revolutionize data transmission. This breakthrough, reported by TechExplorist, reflects the growing synergy between quantum technologies and traditional communication methods, potentially setting the stage for a new era of ultra-secure and efficient data transfer. At the heart of this advancement is the ability of qubits, quantum bits that serve as the fundamental units of quantum information, to communicate effectively through fiber optic cables. This integration is crucial because it allows quantum information to be transported over long distances without being compromised, a challenge that has long plagued the field. The researchers utilized advanced techniques to stabilize the qubits during their transmission, ensuring that the delicate quantum states remain intact despite the inherent noise and loss associated with optical fibers. This achievement is a significant milestone in the quest for practical quantum communication, said Dr. Emily Chen, one of the lead researchers on the project. By enabling qubits to speak the language of fiber optics, we are one step closer to realizing a fully functional quantum internet. The implications of this research extend beyond simple data transfer. They suggest a future where quantum encryption could safeguard communications against even the most sophisticated cyber threats. The impact of this innovation is multifaceted. For one, it could lead to enhanced capabilities in quantum computing networks, allowing them to interconnect more seamlessly with existing infrastructure. As Dr. Chen elaborated, the ability to integrate quantum and classical systems will drive the development of more robust applications in areas such as secure voting, financial transactions, and secure communications for government and military operations. Moreover, this progress is likely to stimulate further investments in quantum technologies, a sector that has already seen substantial funding and interest from both public and private entities, with the potential for a quantum internet on the horizon. The demand for skilled professionals in this field is expected to rise sharply, prompting educational institutions to enhance their curricula in quantum mechanics and related areas. As the world moves closer to realizing this vision of a quantum-enhanced communication network, the next steps involve addressing the scalability of this technology. Researchers are already exploring methods to improve the efficiency of qubit transmission over greater distances and to minimize the loss of information during transit. The journey from laboratory experiments to real-world applications is fraught with challenges, but the determination and ingenuity displayed by the scientific community bode well for the future. In conclusion, the successful integration of qubits with fiber optics heralds a transformative shift in how we think about data transmission and security. As scientists continue to refine these technologies, the prospects for a quantum internet become ever more tangible, promising to reshape our digital landscape in ways we are only beginning to imagine. The coming years will undoubtedly reveal further advancements and applications, solidifying the role of quantum technologies in our increasingly interconnected world.